So Sabrina, how do you want me to go through the review? So start the first one, Jalissa, all the way to the end. Okay, I got you. So you don't want me to deviate at all from that order? You know, that's that. All right. You're right. It wasn't as good. We are here with our period 4 class. All right, with that intro joke. Now we're ready for. All right, we're gonna go right from the beginning. Let's do it. Test tomorrow. Whew. Yes, you're right. So it would be a conditional test given that there is school. I'm on fire. All right. We have number 1, which is talking about a herd of deer. It gives us a function, a growth function. If you take a look at the parentheses, you guys see the 1.13? How do I know that that's growth? Because the 1.13 is greater than 1. It's greater than 1. If it's greater than 0 but less than 1, that would be exponential decay. All right, so if it was talking about the deer are becoming like endangered, right? They're decreasing in population, then this number here would not be above 1. It'd be between 0 and 1. Everybody good there? That's exponential decay. So that's the difference, yeah. Can't be negative, no. All right, so let's write down. I'm not going to give you any formulas tomorrow, but this is the formula that we're going to use. I'm not going to give you any, so whatever you'd like to do. What was that? And a what? I guess. I don't know what you're saying to even say it. And a who? And a like alley oop, but and a oop and a oop like that. Sabrina, I'm old. Okay, I'm sorry. All right. I should do what?
You should get Twitter.
I am on Twitter. But we follow different people.
Yeah, you're not on the same Twitter.
Is it appropriate?
Yeah.
Okay. I just want to make sure. All right. Why don't you pre-screen? You watch it. Okay.
I never knew that.
Okay. That's it.
I heard the video. Yeah, the video from the beginning is me. The whole video is funny. The whole video is hilarious. Yeah.
Let's just get back to number 1. I'll check it out on my own. All right. So we have these deer, and we think they're going to grow every year exponentially. And in 6 years, we want to know how many deer there will be. Okay, so I'm going to plug in A of 6 equals how many deer to start. It tells us 205 times 1.13 to what power? The 6th power. All right, so if you're using the yellow calculators, you can find out how many deer we expect in 6 years. What's up?
Actually, it's Thursday.
It is Thursday.
It felt like
3 weeks.
Tomorrow will be a Wednesday.
So what is it? Wednesday? I hate Wednesday Friday. Like, I don't know.
Yeah. So it's, I think, is it 427?
420.
But then when you round it to the nearest whole numbers? Okay. 427 deers. It's not. You're right. It's not. It's not correct.
Oh, it's not?
Yeah. It's like, 1 or more.
Oh.
So there's no such thing as beers?
No,
No.
no, dear.
I got a lot of John Deere's in the back.
Oh, there's no. So where there's
In the back, what is it?
kind of like cactus.
Mm.
You have deer. Like fish.
Like fishes. Yes.
Like
So it's just, I have.
Like
to-
moosin,
fish.
meese.
But how would you say fish?
Fishes. 3 fishes.
Wait, I thought it's
This is fun. All right. Let's go to number 2.
I think we need to go back to.
What? 7 meese.
Are you trying to say mine?
No, yeah.
It's meeson.
She was like, she told moose and
One of these days, someone's just going to get up and walk out and be like, I had enough of it. Okay.
what's going on?
Number 2 is what's going on. We're going to number 2. Yes, we are. Number 2.
It's called
Number 2. Now,
Let's learn our tests tomorrow.
you'll notice that we've changed. I know. You'll notice that we changed the formula just a little bit. Yes, Jalissa. No formulas will be given to you. No. But these are really the only formulas. Just these 2. So if you can memorize this one, I would memorize this one. And then when you do the exponential growth for the deer problem, just take out the ends. Right, the one we just used is just like this, but there's no ends. Yeah, 1 plus r and then raised to the t. Probably, yeah. But it won't be deer, it'll be deers. No, never mind, I'm not going back down that road.
No, it says deer in the problem.
Oh, good question. So that one did give it to you, but this problem doesn't. So
Like, I'm saying that you're saying, like, it'll give us.
I can't promise that, but I think I do. But I don't want to lie to you. Okay, so I think I do. All right, so we have, how much money is this person putting into their account right now? 8,500. Okay, what's the rate of growth we're expecting? So that's going to be 0.0812 over. Now be careful here. This is compounded monthly. What am I going to put for n? Very good, 12. All raised to the nt, so 12t. So this is the formula that you could use for any years. 3 years, 4 years, 8 years, or even 20 years, which is what they asked for. So I'm going to plug in a of 20. So it's just like number 1, but you had to know the formula and make the formula, unlike number 1. Now it's up to you how much work you want to show. I will tell you, if I see this, that would be enough work for me. But tomorrow the test is multiple choice, so it's up to you how much, the whole thing, yeah. 20 questions. Mm-hmm. Okay. All right, is everybody good on this? And then it becomes plugging in. So I don't know if anyone wants to do it. Only one person seems to be using a calculator. Sabrina, thank you. You already did it? Oh, sorry, I know about that. But if you check the key, I think it's like 42,000, 888, something like that. Cool. Now, if the test has, rounded numbers, just find the closest one. What? Why are you laughing? Okay, everybody go with 2? All right, let's go to 3. This is where it gets really challenging. All right, number 3. We have Helen, who wants to save up $5,000 to put a down payment towards a car, to lease or buy a car. All right? I'm sorry? Yeah, the light just came on. So we want to find out how much she needs to put into an account today that has an interest rate of 7.5% compounded daily in order in 3 years for her to have $5,000. All right, so let's write that formula again. A of t equals P times 1 plus the rate over the number of times compounded raised to the nt. Now, before I do this, I always try to ask myself, what am I solving for? What do I want to find at the end? And the answer is P. All right, we want to find out what amount of money she has to put into the account today. All right, so that's P, the initial deposit. So I'm going to write a big P. 1 plus, what's the rate? 0.075 over, be careful here, compounded daily. Very good. There are 365 days in almost every year. Raised to the 365t. Now there's one more piece of information that's going to allow us to find P, and that's the $5,000 in 3 years. So where's 5,000 going to go? Okay. Solving for P, 1 plus 0.075 over 365 to the 365 times 3 years. Now, my recommendation, if you're doing this, would be to take everything that's to the right of P, the 1 plus 0.075 over 365 raised to that power. Do that in the calculator first to get like a number. Can anyone do that for me? What'd you get? What did you do in the calculator to get 0.25? This right here?
Yeah.
Can you raise that to this power?
Wait, the reason why we didn't put 3 on the other side is because of the 5,000?
This is A of 3. You could think of it like that. This is A of 3. 1.25, it goes on further, right? That's fine. For the work, you can round it. Just make sure that when you are still working the problem, you don't round it till the end. Okay? So now do 5,000 divided by that number, and you'll get your answer. No, shouldn't be 0. Did you do 5,000 divided by 1.25? Da, 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 da? So basically, we're telling her to go to the bank or wherever she's doing, probably online, and put in $4,000. That's right, because it's only an interest rate of 0.075, and it's only been 3 years. That's not a lot of time. Now, I had a student in my other class say, wait, hold on. You're telling me that she's got $4,000 right now, but she's going to wait 3 years to put $5,000 towards a car. Why not just put $4,000 towards the car? Like right now. I said, yeah, I mean, you can. I mean, it's up to you. Like ultimately, it's your decision. We went on this big tangent about buying a house, what that looks like. So if you... Now, if I go down this road, that means I won't get as many done here. I did record that class, so you can listen to it if you'd like. Uh-huh. Okay? Pretty much. Again, if you want to learn more about mortgages, listen to period 1. I did not talk about reverse mortgages. I just talked about buying your first house. We did not do that. If you would like to know more, please Google reverse mortgage. What? Stop, Galileo. Let's go to number 4. We should probably offer a course like that, right? Senior year. Several courses. Like about a mortgage, like what it means to buy a house, what it means to like have utilities and. Ooh, that'd be a good idea for like your social justice thing, like somehow work it into financial things. Yeah, I mean, I just usually if I ask the internet or ask my dad or my mom, that's all I ask. It's a good thought. Okay.
Wait,
What was the question?
I'm just like wondering like how much of a difference is renting a house versus renting an apartment? Like if it's worth renting an apartment.
Well, renting is usually by location and square footage.
Yeah, but like, you know, like, I guess like money-wise,
Well, like I feel like you want me to go down this road, but now I'm like,
That's how I'm thinking, right?
depends on the apartment. I mean, what are we talking about here? Your first apartment and your first job. How much are you making your first job? How much are you making your first job? I mean, we have to come up with parameters. You can't just be like any question. How much money do you have?
I mean, right now, it's just.
40,000 a year for your first job. You're 22. I mean, you probably for a one-bedroom apartment, you probably don't want to spend more than 2,000 a month on that apartment. 2,000 a month. That'll get you a pretty nice apartment if in the loop. What's up?
You said you only make 4,000.
40,000. In 2 months, you're out. So what most people do is they live in an apartment for, I don't know, 1 to 5 years, 1 to 10 years until they have enough for a down payment on a house.
But I've known like some apartments are more than actually renting a house.
Yes, all renting and owning. Are you talking about renting and owning or renting and renting?
Renting and renting.
Because renting a house is probably more expensive because usually houses are bigger. So I would not recommend renting a home unless you're living with other people. Right? If you're going to be by yourself, then just get a one-bedroom apartment. You can buy a nice one in, like, if you're working downtown or Galleria in the Loop. All right? That's pretty nice for $2,000. There's traffic everywhere. I mean, where are you going to go?
That's bad though.
It's bad. I'm with you, but that's where the money is.
I want to own a house.
That's where you should want to get to home ownership, because with rentals, you're not actually gaining anything in terms of your equity, right? There's no actual money to your name. When you own a house, you have something, you have collateral that you can use. So you definitely want to own a home at some point, right? I mean, my goal was by 30. I don't know why I checked my watch, but still 32. By 30, I wanted to have my first house.
Are you already 32?
32.
When did you get it?
Yeah. I bought my first house at 25, but my goal when I was 18 was to have my first house by 30.
How much money did you have saved when you were 18?
Not a lot. Why don't I do this? Why don't we, since we're like cutting to this time, why don't next week, when we're reviewing for the final, I just do a day on that?
Yeah.
How about that? Let's do that. Of like, if you will come up with like what you think, you guys can pick what job. There we go. That's what I'll do. Perfect. I'll definitely do that.
Reverse mortgages. Yeah, reverse mortgages.
That's not something you should ever need to worry about.
Wait, so it's not going to be on there?
You can ask about it, and I'll give you a quick answer. Usually that's for people that are not financially well off. Let's get back to this. Okay? No, I'm...
Do you want to move out right now?
All right. Let's graph this. Let's make a T-chart. The numbers I usually tell students to use are -2, -1, 0, 1, and 2. If you have the yellow calculator, do you remember where you can go to type this function in?
Table.
Very good, table. So if you have a calculator, you can go to table.
I'm learning.
I'm so bored.
No, it's I'm learning as well.
Learning while doing. Yep.
Yeah.
Do you need one, Jalissa? There's one right behind you, on your right. There you go. You need one, Peter? Go on. All right, so you should be typing in 3 to the x power if you're using table. Again, you can start wherever you want. The biggest thing is make sure your step says 1. Make sure your step says 1. All right, so what is 3 to the negative second power? 1/9 is correct. 3 to the negative first power? 1/3. 3 to the 0 power? 3 to the first power? And 3 squared is 9. So let's plot these points. And when you plot that, the first thought should be that this is exponential growth.
I knew that.
How do you know it's exponential growth if you don't look at the graph, Yesenia?
It's going up.
If you don't look at the graph.
Oh, if you don't, well, if you look at the little points, they're going from these to like,
You can do that, but if you don't look at the graph.
but I'm not looking at the graph, I can't see it.
Yeah, but if you look here, the function.
I don't know.
What's the base?
3?
It's 3, and that is greater than 1. If your base is greater than 1, it's growth. So if this would have been, instead of 3 to the x, 1/3 to the x, like this, 1/3 to the x power, that would be decay. Because 1/3 is between 0 and 1.
How do you find the table?
Between 0 and 1 is decay. Hit table. Type in 3 to the power of x.
How first A?
There should be the x button somewhere next to number,
Oh, it's over at the bottom.
should be in the exponent.
Oh.
Carrot, even though it doesn't look like a carrot. Okay, what's the domain? All real numbers is correct. I use interval notation, so negative infinity to infinity. Basically, we're saying you can plug in any value for x. What about for the range? 0 to infinity, our lowest y value. We put 0, but notice, is this a bracket? No, because will we ever touch 0? No, we'll get really close to it. What's that called? Very good. That's why they ask you for the horizontal asymptote. What's up? So y equals 0. And I told you guys when I taught you this last week that this is always a good mental check. Those should match. Okay, let's get this to be a little bit more challenging. Number 5 asks you about transforming it, so moving it around. All right, let's do that. That one's a little tougher. That's probably that'll be probably the most missed question tomorrow. All right. So let's do 5. Okay. I'm just waiting for people to get done writing before I delete it. Sorry.
I know.
Okay. Now, this right here, the goal is to write down the equation for this function. Okay? Now what they've done is they've told us that it starts from 2 to the x power. So if I were to make a t-chart and plot 2 to the x power, and use our -2, -1, 0, 1, and 2 like we did before, I would have 1/4, 1/2, 0, 1, 1, 2, and 2, 4. If you don't know how I did that, all I did was I did 2 to these powers. Yes, everybody good? So I'm going to plot that in black. Okay. Now, this is how I would recommend doing it on the test tomorrow. So I'm going to change to blue so you know that now I'm talking about the new one, the one that we want to actually find. I'm going to call it g of x. Now, I always know it's going to stay 2 to the power of x. Where is the new asymptote? On this black one, the asymptote is still y equals 0. Where's the new asymptote? It's down here, right? -2. So whatever the new asymptote is, that's the shift up or down. So in this case, we're shifting down 2. So way out here at the end, I'm going to write -2. Now, it's just a coincidence that these are both 2. All right? What if my asymptote was up here at 4? Then this would be +4. Now, here is, I think, the hardest part. So make sure you're focused and paying attention to this part. This is the most challenging. What I tell students to do is, okay, do you see this point 0, 1? We said we're going to move it down 2. So if I go down 2, it's right here. But is that on the blue curve? No. So where do I need to move to get it on the blue curve? Right 1. So I'm going to write right 1.
We gotta do that?
Yeah, you're going to do it tomorrow.
Okay, can you explain?
Sure. Are you good on how I plotted 0, 1?
Okay.
Yes? Okay. So I went down 2, it's right there. But it's not on the blue curve. So if I move 1 to the right, now I'm on the new curve.
So you want it to
I want it to be on the curve. I want to know how far left or right do I have to move. In this case, just 1 to the right. Now, how's that going to look in the exponent when it's right 1? It's -1. All right? So don't forget to always think opposite when you're working horizontally.
That's the equation?
That's it. That's the answer.
You have to write it like that.
Well, it'll be multiple choice, so it will look like that, yes. Okay. Again, I think that'll be one of the more challenging ones. All right, let's keep it going. You sure you don't want me to deviate at all? If you want me to keep going?
Oh, these three.
So you want me to skip?
No.
Let's not. Which one, Sylvester?
I was saying, if we just handle those one first, then we can.
All right, so logs handle this first and then deviate?
Yeah.
All right.
That's the main thing.
Okay. Or we can just.
Well, are you writing any of this down?
I'll take like pictures.
You know they've done studies about people who write things down, right?
I mean, I got it down on my review guide.
I understand, but where's the paper I asked you to get out?
I got it.
Did you take that from the tub?
For years.
All right. Let's rewrite log base 17 of 4,913 equals x. So that's going to be 17 to the power of x equals 4,913. And we're done. Yay. Okay, let's go the other way. Log. Oh. What was it? Any oop, alley oop, any up, and o. Log base A of B log of equals. Very good. Log of equals -2/5. Or logab. It wasn't even funny. Log of abs. Zac Efron. Okay. Log base 5. What movie? He's had a lot of movies. I haven't. It's on Netflix though. Is it really good? Okay, don't spoil it.
What is that?
The catching.
Dude.
Oh, the time.
Is it good? Okay. Yeah, we were joking. Okay, log base 5 of 125th. If you're having trouble with this, 5 to some power equals 1 over 125. So why do you say negative something? It is negative something. Why do you say that? Because it's a fraction. More importantly, the fraction is 1 over the big number, right? It's a fraction that's going to be less than 1. So when you look at this, ask yourself 5 to what power gives you 125? The third power, so the answer is just negative 3. Still asleep. You're good. I mean, he was here on Tuesday, so he was already plus a day. You feeling okay? All right. I just figured you're going to watch it later. All right. We're talking about reverse mortgages.
We are?
God bless Mark. All of these?
No, I'm good with that.
Number 9.
No, yes? Okay.
Yes.
Okay, in number 9, do you see how there's one log and there's 7r times 11s? But there's also 7 times r and 11 times s. So yeah, you're going to separate them all out with addition. So there's going to be 4 logs.
And that's when it says expand.
Yes, so the expanded form here means that you want multiple logs. Condense will tell you to do 1 log. So this is going to be the log of 7 plus the log of r plus the log of 11 plus the log of s. All right, and it's because it's all multiplication. That's it. Because it was all multiplication in there. If there had been any division, then I would have had some subtraction in there. That's coming, don't worry. Okay, number 10. What? If you want to, yeah. Okay. The log of r squared plus the log of s to the 11th power. Why did I put plus there? Because they're multiplying. Very good. And then minus the log of t to the 14th power. Now, most students stop here, but you can go one step further. Do you see all of these powers? You can put them in the front. And you should put them in the front. So it's 2 log r plus 11 log s minus 14 log t. That is the answer. Yes. Number 11. So we need one logarithm with a big argument. What's going to be the argument? Z over x, y. Now, why did x and y go on the bottom? Because they have subtraction before their logs. So subtracting means division. Subtracting means division.
Wait, what? That's the answer?
That's it, yeah.
Would y be also divided?
It would, but watch this. So if you have z over x divided by y, when you do that, you have times 1 over y, so you're putting them in the same spot. When you see addition, it's in the numerator. When you see division, it's in the denominator. Cool. And the first one, if it's positive, the first one is in the top. Okay, number 12?
So if it was plus log y, it would have some.
Correct. All right, number 12. The first thing I'm going to do is I'm going to move those numbers in front. Where am I going to move them? To the back. To the power, is more mathematically correct. Where are you going to be? I'm going to be in the back of the room. You mean the power? That was for me. Is everybody good with the first step there? Putting the powers, like the numbers in front to be powers? Okay, let's see what you got. Who wants to give it a go?
Oh, the whole thing.
Yeah, what do you got?
B to the third times W to the sixth divided by, that's just.
It's a U.
U to the 1/3.
There you go, you're good. Okay, and that's fine, you can be done. Personally, when I have powers that are fractions, I make them into square roots. In this case, it's not a square root, it's a cube root, but you don't have to do this. That's just my preference. Either one is fine. Oh, yeah, might be. Thank you. I missed the 7. Yeah, feeling good about it?
Kind of. I'll probably forget it.
You went from I got this to kind of in just one question. You can do this. You can do this. My friend, did I tell you about my friend? He's taking stats at online through HCC. So he's asking me, you okay? He's asking me a lot of questions about stats. And he's just very nervous all the time about the exams that he takes. He's taken 4 tests. What's the lowest score he's got? 92. And he's got his final coming up. He's like, man, I don't know. I don't think I'm going to do it well. I was like, dude, 90s on all your tests. You got this, okay? You can do this. Then joke's on me, I guess. I don't know. I mean, joke's on him. He paid for it. All right. Okay, should we bounce around here? We got 15 minutes.
Yeah, that is 16.
Start at 16? I think we should do one of the... Ooh, well, what I consider the most challenging? Yeah, but they're all kind of like a little nuanced, all of these. So I think we should do 14 and 16. Let's do that. Let's do 14 and 16. Perfect. So when you look at 14, what's the plan? What's the plan of attack on 14? Yeah.
And 7, put like American 7.
That's right. Not 7, 2, 7 squared, right? And the right side isn't going to change. But what do I have to do with the left side when I have a power to a power? You multiply. So it's 7 to what power? Yeah, and what's the most common mistake students will make there? Exactly, Kayla. That's the most common mistake. Students won't put this as 2x. They'll forget to multiply this 2 times the second term. Make sure. You got to do both. All right? Now, my brain knows that when they have the same base, I don't want to actually do that. When they have the same base, all I care about are the exponents being equal. So I'm going to write down 18 minus 2x equals x minus 3. All right, which direction do you want to move the x's? Personally, I would move the minus 2x to the right. What does that become then? Positive 3x. And then I move the minus 3 to the other side with addition of 3 to get 21. So x is 7. Tomorrow when you take this, once you get an answer, what should you always do? Plug it back in to see if it's right. And you know the answer choices are all there. Okay? You'll have A through D. Oh, yes. So you could just go right then. That's the answer. That's what makes this true. Basically, if you want to check it, we're saying 49 to the second power is equal 7 to the fourth power. We're saying that if you use your yellow calculator, you get the same number for both of those. I always recommend checking it, just because if you check it and you didn't get the same thing, maybe you're like, oh, I might have messed up, and you can find your mistake. Okay, let's do 16. Now, why is 16 different? Now, we had x in the power, just like in 14. Can you rewrite 12 using 3? No, because 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27. Extra. So we need to do what? Take the log of both sides. Now, the whole point of doing that is it allows you to take the exponent of x minus 4 and move it to the front. Correct. Now, when I taught you this on Tuesday, only a couple of days ago, I had you guys multiply the log times each term. So what's x times log of 3? X log 3 minus 4 log 3. Now, if this says minus 4 log of 3, what is it going to be when I move it over? Yep, it's going to be log of 12 plus 4 log 3 is equal to x log 3. And to get x by itself, we need to divide by the log of 3. So x is equal to log 12 plus 4 log 3 over the log of 3. So this is the answer. There's another answer that is acceptable. All right, this is one of them. There's actually a couple, but this is one answer, yes. When you have one log in the denominator, you can actually do some division here. I'm not going to divide the arguments, like the numbers that come after log. I'm not going to touch them. But I can divide each of these by log of 3. So I could also write it as the log of 12 over the log of 3 plus, and now when I divide this one by the log of 3, the log of 3's will cross out and leave me with just 4. So this is another way you could write it. Either one is fine. Okay? Pretty good? All right. How many questions are left? 17 through what? Through 25? Oh, just 17 through 20? Nice. Awesome. Just like the test. But the test does have vocab. The test has vocab. It's matching, yes. God forbid I make you do short answer vocab. I didn't. Excellent. Do you remember like the memory games growing up? You know, like matching the cards? Yeah, we're doing that right now with Henry. He doesn't really understand it yet. He just like we were playing 2 nights ago, and he picked up, it's Paw Patrol, obviously. He picked up Rubble, and then he was holding Rubble, and he picked up Chase, put Chase down, picked up the next card, also Chase. And I was like, dude, you made a match. He's like, no, it wasn't Rubble. I was like, yeah, but put Rubble down and pick these guys up. We'll get there. Okay. Which one? 20? Okay. Do you remember our 2 goals?
Yeah.
One log. There you go. those are the two goals that I'm trying to focus on with logarithmic equations. And in number 20, it's almost as if we have achieved goal number 1, because there's one log on one side. But what do you see that's outside the 2x minus 2 on that argument? There's a power of 3. So using the power property, where can I move that? To the front. And then if it's multiplied by that log, how can I move it over? With division. So now we have the log of 2x minus 2 equals 1. Now we have one log on one side. This is where you're going to swoop. Now I don't see a base. So this is what we call a common logarithm. Very good. It's a base of 10. So common logarithm. So 10 to the first power is 2x minus 2. Now you should be able to solve that. Solve for x, yeah. I believe x is 6. Yeah, I just skipped some algebra steps. All right. Why don't we do 17? 17 has 3 logarithms. So it's definitely not goal number 1 or goal number 2. Because goal number 1, there's only 1 log. Goal number 2, there's only 2 logs. When I see 3, that means I need to combine at least 2 of them. So do you guys see the left side where it says log base 2 of x plus log base 2 of 7? I can combine those to be log base 2 of what? Actually be 7 times x. You could write x times 7, that's fine. But a common mistake students do is they still use addition. But when you see addition, you should be thinking multiplication. And once you have one log on both sides, similar to when we solved the exponential equations, these arguments have to be the same. So 7x has to be 21. Let's do that. I think you guys can do 18 and 19 based on what we just did. Okay, we got about 5 minutes. Any last minute issues before tomorrow? You know, I posted a key.
Even better.
Even better. I heard 13 and 15. I wouldn't really worry about 15. Can you do 13, 14, and 16? Then you're good. I think you do 13. Jalissa, you're asking about 13. How would you rewrite 25? Was it not you, Jalissa? Oh, okay. You would rewrite 25 as 5 squared. And then you would set 4x minus 10 equal to 2. All right? 19? Yes. How would you put those together if you see subtraction? You would use division. Nah, it'd be x over 2, because the first one is always the numerator. See it? And then you can swoop. Again, there's no base, so it's 10 to the second power is equal to this fraction. What's 10 squared? So what number divided by 2 is 100? No. 10 divided by 2 is 5.
Oh, okay.
You're good. 200. There we go. All right. You guys are ready. The bell's going to ring in like 2 minutes. Can you just wait till the bar is?